Bienvenidos, Ushamdi, and welcome CTS230, Section 841 students for the first 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 3 or the Scaling Networks V6 course, and this morning's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 9.2.2.7, which is going to look very familiar and just like Activity 9226, except here, we're going to be working with Multiarea OSPFv3. In other words, OSPF for IPv6. So let's go ahead and dive into the activity. You're going to see it's literally an identical activity from a topology perspective. We've got instead of router 1, router 2, router 3, we have router A, router B, router C. We have the same areas and much the same setup here. And you'll notice we're not asked those same questions at the end of this activity because very good possibility that the answers would be very, very similar. So let's dive in here. Let's knock this activity out. So we've got the first step on router 3. Router A, we need to configure OSPF v3. And so let's bring router A back up. We'll go to the CLI here. And we'll go from user exec to privilege exec and then into global config. And we are going to enable IPv6 unicast routing, right? Remember, we have to do that or we would end up with an error. And then I'm going to say IPv6 router OSPF and the process ID, which is locally significant for our purposes, is going to be 1. Now you'll notice we don't have the router ID configured. There are no IPv4 addresses on this router. And if I said do show IP interface brief, why don't I see 1111? I just configured that as the router ID. How come that doesn't show up here as an IP? Exactly, because it's not, right? Remember, the router ID, it can be an IP address that's on the router. If that's how it's selected, then it would. But remember, when it's in the context of the router ID, it is not an IP address. I can't say up here, do ping 1.1.1.1 and get a response back because it's a router ID. It takes the format of an IP address, that 32-bit dotted decimal notation. That's the format of the router ID. But it is not an IP address on this router, especially in this instance here, although sometimes it can be if it was a loopback address where it got its information, right, where the router ID selected it from a loopback address because we didn't manually hard code it, then there would be an IP that matched the router ID. But remember, the router ID is not an IP address. You cannot ping the router ID. Okay, so we've got that set up, and then, this is the thing I like about OSPF v3 is you have to go do show IP interface brief, probably the same interfaces, do show IPv6 interface brief. You have to go under the interfaces to make the configuration changes, right? So it's simply IPv6, OSPF area, and for the serial 000 interface on router A, that is our link into OSPF1, area 0. That is our link into area 0. And then we have 2 additional interfaces, gig 00, and this is where we can simply leverage that up arrow, leverage the up arrow, but making sure we get the area correct. And fortuitous failure, take a look at that, right? That's why I leave a lot of the mistakes in, because you're gonna make mistakes. And let's see what happens when I put the wrong area in here. Take a look at that. We're now getting syslog messages telling me area mismatch, because on gig 00, I put it, and I'm assuming that's probably gig 00 here. Yeah, A11. So this is the area 0 link here. Well, over here in the cloud, they're configured for area 1. So I put the wrong area in, and that's the problem, right? Take a look at that. You'll also notice that it gives us the area number in 32-bit dotted decimal notation. That is also a valid format to enter an area, although I don't see that too often. You typically see an integer number, not a dotted decimal representation, but you could, if you wanted to, put it in dotted decimal notation. Okay, so let's fix this. Let's say IPv6 OSPF area 1, and there we go, and that's going to take care of that problem. So we go to gig 00, or I'm sorry, 01, and we put that interface into area 1. So now we have adjacencies with neighbor 11.11.11.11, and we should end up with another one here shortly. All right, so let's configure router B the same way, and B will be easier because all of the interfaces, it is an internal router, and all of the interfaces are in the same area. So let's knock this out here. We'll go from user exec with the enable command to privilege exec, configure terminal into global config, IPv6 unicast routing, IPv6 router OSPF1. Let's set that router ID to 2.2.2.2. And now we simply pick off the interfaces of router B, int gig 00, and it's going to be IPv6 OSPF, 1 area 0. Same thing for interface serial 000 and interface serial 001, right? Very, very straightforward. We should see 3 adjacencies pop up here, right? One with the cloud, one with router A, which is 1111, and actually we'll see the third one with router C here in just a second. So now let's validate. What do we see so far? So do show IPv6 OSPF neighbor, and let's get OSPF spelled properly here. And there, it looks like router 21 is out in that cloud space, right? And so there's our information. Now, very important here, with router 21, we are simply two-way DR other or druther, but look at, we transition to full designated, and again, designated router, meaning that router 21 is the designated router, right? Here is our DR, BDR priority setting, right? The priority by default on multi-access segments is 1, and these are not IP addresses. These are the router IDs of the routers that we are neighbors with. So there's router 1, or router A's router ID, and here is the cloud in area 2's router ID with whom we have an adjacency out gig 00. So now let's go ahead and knock out router C. And we come here to the CLI, and we go from user exec to privilege exec into global config, and we are going to say IPv6 unicast routing, and then IPv6 router OSPF1. Let's set our router ID here. And then let's get into the different interfaces. So we're going to go do show IPv6 interface brief. And I think it's going to be gig 00 and 01. The mouse, for some reason, is not grabbing. There we go. Yeah, gig 0001 and then serial 001. So we'll start with serial 001 because we know that this is going to be IPv6, OSPF1 area 0. And then gig 00 is going to be area 2, and gig 01 is going to be area 2 as well. Excuse me, so we should see the adjacencies form with these other routers, the cloud routers. And so if I was to say do show IPv6, interface brief, do show IPv6 OSPF neighbor, and you can see we're two-way DR other, but that's because we're transitioning through the OSPF state machine, right? We go from down to init, from init to two-way, from two-way to EX start, EX exchange, loading, and there's our EX start, right? And EX and the exchange, and then from loading to full, and that's where we see that message. And now we can see the status of everything. So why is there no DR BDR here? Exactly. Remember, that is a point-to-point. So if I was to say, do show IPv6 OSPF interface, that serial interface, what kind of an interface is it? It is point-to-point. What about these other guys down here? These are broadcast interfaces, right? Or the network type is a broadcast network type. Up here, we've got this network type. Sorry, we grabbed the wrong thing. Network type point to point, right? Point to point. Network type down here is broadcast. So that is why we don't have a DR BDR up here, is because it is a point to point. There's only 2 routers that can be there. We don't need to have a DR that everyone becomes adjacent with, because on a point to point link, there is no everyone. It is literally the 2 sides of the link. That's it. Right? So we don't need to introduce some sort of a mechanism to provide scalability on point-to-point links, because there are only 2 things on either side of the link. All right, so that's the activity, but let's look a little further here at some of the things we looked at in the other activity to see what they look like. What about the OSPF database here on router B? And actually, I'm going to take a look on router C. So let's make this a little larger here on router C. So we stretch router C out, and we say show IPv6 OSPF database. So remember, router C is an ABR, so we're going to see information for area 0, which we're looking at right here. And here are my type 8 LSAs, right? Those 2 additional LSAs. And now, what do they call? They renamed the type 3 LSA. So it's not a summary LSA anymore. It is an inter-area prefix link state LSA, which is the equivalent in OSPFv2 of the summary link state. The concept for scalability remains the same here, right? We're breaking this OSPFv3 setup into multiple areas for the purposes of scalability. And it could improve convergence time. Remember, we talked about the full SPF run having to be done. And that's something where if this link here were to go down, we would not have full runs out here in the other areas, right? Maybe a partial run, but not a full run. And so that provides scalability as well. And here is the summary information. So let's dig down a little further, show IPv6 OSPF database inter-area. Inter-area prefix. And so here is that type 3 LSA, right? The inter-area prefix LSA, and it's for area 0. And look at the advertising router. It shows 1111. We know that that's router A. And here's the 2001 DB8 1A1. So here is the network. And again, this is a critical conversation to have with respect to the abstraction, right, or the hiding of information between areas, right, that gives us that distance vector characteristic of multi-area OSPF is really distance vector. And again, Moy says as much in his book on OSPF. And so what do we get? Okay, so there's the advertising router. Here is, well, we see the metric, right? And we get the prefix address, right? So think of this as a subnet for IPv4, right? This would be a subnet, and my pin is on the fritz. Subnet. So this would be the equivalent of the subnet, but we know it's the prefix. And then this would be the equivalent of that, that /24, the subnet mask, right? Or the subnet length. But we're seeing it here for IPv6. And in IPv6, remember, it's prefix and prefix length. But again, it's a summary of these networks being communicated as type 3 LSAs, and in IPv6 or OSPF v3, we call them inter-area prefix link states, right? But that's all they are. It's the same information that we saw in IPv4, the metric, the prefix length, the advertising router, so that router C knows that if he's getting traffic that's destined to that prefix, he can recurse and figure out, oh yeah, I have a type 1 LSA for router 1111. I know how to get over here to router A. And all of the other routers in area 2 that sit behind router C, I almost said router 3, that sit behind router C, so all these guys out here, all they know is I have an OIA route. I have an OIA entry in my rib to get to these networks, and all these routers know. They don't know anything about what's going on over here, right? Which goes against the concept of link state database, right? Against a link state routing protocol, is these routers know nothing about what's going on over here. Absolutely nothing. All they know is that to get traffic to these prefixes, they have a type 3 inter-area prefix LSA that is saying, no, don't send it here. You just send it to router C. Just send it to your friendly neighbor, router C. He will make sure the traffic gets there. And that is all these guys know about with respect to these networks, is router C is telling me, come to me, I'll get you there. And so again, right, if this was EIGRP, you would look at it like this, is they're just big routers, right? That each area is a router, just like it is an EIGRP, like EIGRP distance vector. We have that same, let me get rid of that first. So if these areas were looked at as just being routers in a distance vector sense, that's exactly what we have, right? You've got routing by rumor, where area 0 is telling area 2, hey, if you want to get over to these prefixes, just come in to me, come to area 0, or in other words, router C, and he'll get us over there, right? And that's all it is. That's distance vector behavior. That's exactly what it is. It's the abstraction of the information from one area via a type 3 LSA into other areas. And that, is multi-area OSPF. Okay, that is going to wrap up our conversation on multi-area OSPF. We're now going to go into that scaling networks OSPF monster activity, just like the EIGRP activity, but they are fantastic activities. Okay, thanks so much for watching. I will see you tomorrow night.